Let's look at another example of long division with polynomials. Okay, this is a polynomial. We would call this very specifically a binomial, right? And remember that a fraction means division. So what are we doing? We're taking x minus 3, and we're seeing how many times does that fit. And notice what I'm doing here. If you're like, why are you writing such a long line for just 2 terms? Okay, we want to see how many times it fits into this polynomial. Now, one thing I mentioned in the introduction video prior to this is that every exponential term of x has to be represented in this dividend. So even though there is no x term in this, we need a placeholder for x squared, okay? We need a placeholder for x, and then we have the minus 7 afterwards. So every exponential term of x has to be represented in this divisor, or excuse me, in this dividend, okay? And then we start by saying, all right, we only look at this x when we're asking, how many times does it go into this? How many times does it go into that? So what do I multiply x by to get x cubed, right? And the answer to that is x squared. So I write my x squared above the x squared term. Then I take this and I multiply it times this. So x squared times x is x cubed. X squared times negative 3 is negative 3x squared. And then I subtract these, just like I would in a regular long division problem. X cubed minus x cubed is nothing. 0, and got to be careful here, 0 minus negative 3. Okay, I'm going to emphasize this. We are subtracting negative 3. You've got to pay attention to this. Don't just do 0 minus 3 is negative 3. It's 0 minus negative 3. And 0 minus a negative is 0 plus, right? So we do 3x squared here. And then we repeat the process down here instead of up here. What do I multiply x by to get 3x squared? And the answer to that is 3x. And that 3x term goes above this x term. And then we do 3x times x, which is 3x squared, and 3x times negative 3, which is negative 9x. I bring this x term down so that I can match this up for my subtraction. I'm not going to bring the 7 down because I don't have another term to subtract that from. 3x squared minus 3x squared is nothing. 0 minus negative 9. Again, we're subtracting a negative, so that's addition. So this is 9x. Start over. What is x? What do I multiply x by to get 9x? Positive 9. Then I do 9 times x, which is 9x. 9 times negative 3 is negative 27. Bring this negative 7 all the way down. Notice how I'm lining things up here. All right, my 5th grade daughter is doing long division right now, all right, with just basic numbers. And it drives me crazy when her numbers get all out of line and just, askew, because keeping things lined up is crucially important to organizing this problem, okay? 9x minus 9x is nothing. Negative 7 minus negative 27 is really negative 7 plus 27, which is positive 20. Start over. But now when I say, what do I multiply x by to get 20, there's no x here, okay? So this, anytime we end up with a whole number here with no variable, this is our remainder, okay? So let's talk about how do we express this. Remember why we're doing this. Why are we doing division? Okay, we're doing division because we want to know what do we multiply this by to get this, right? This is factoring, right? It doesn't say this, but it's going to in the very next lesson that we do. We're going to say factor this expression, okay? And when we factor it, if we think we know one of the factors, that makes it simpler. We can divide by that and then go from there, okay? So when we do this division and we end up with a remainder, okay, this is crucially important. Couple of conclusions to make here. There's a remainder. Therefore, x minus 3 is not a factor of x cubed minus 7. If it was a factor, I wouldn't get a remainder. Think about this for a second, okay? What's 16 divided by 8? 16 divided by 8 is 2, no remainder, right? Which means 8 is a factor of 16. Well, what's 16 divided by 5? 16 divided by 5 is 3 1/5. That's a remainder, okay? Which means 5 is not a factor of 16. So when we do division and we end up with a remainder, that means this number doesn't go into this an equal number of times. This is crucially important to understanding what we're going to do next, which is the fundamental theorem of algebra. Okay, now, how do we express our answer? Well, we did this division. Okay, when we did this division, the quotient that we got was x squared plus 3x plus 9, but we had a remainder, okay? How do I express the remainder? The remainder is always in the numerator, and then the divisor is in the denominator. So we express a remainder by taking this and putting it underneath our remainder like so, okay? This is how Math Excel is going to want you to express that, okay? Now, I hesitate to show you this next one because it's a little bit more complicated, but I'm going to show you anyway. Or a different way of looking at this is to say this polynomial function, x cubed minus 7, which we were trying to divide by x minus 3. We didn't get there. We know that if we do x minus 3 times the quotient that we got, we didn't quite get all the way to here, right? This does not multiply to be this because of this remainder. So a different way to express this is to say, all right, if I did multiply these together, I'd need an extra 20 to get to that. Now, I will tell you that Math Excel pretty typically wants this written with the quotient. This is the quotient right here, the answer that we got, plus the remainder, okay, right here. But if they want it written like so, they would say, they would show you this format where show the product of these and then add the remainder. But when we add the remainder here, we don't write this underneath, okay?